Hi there, so it's our last lesson before we all see each other in school again, which will be nice. And we're going to look at the trickier questions towards the end of that trigonometry stuff that we can do. The actual trigonometry won't be any more difficult, it's just about spotting how to make your right angled triangles, which you can then use the sine rule from. But before that, we've got a little number starter. Two little ones, an easier one and a trickier one. So see what you make of this. Right, hopefully you know the rules on these by now. We need the numbers from 1 to 9 in these boxes. We'll do the easier one before the harder one. So pause the video and give it a go. Straight away, because we've got 2 out of 3 here, there's only one number that this could be. 3 take 5 is negative 2. Negative 2 plus 8, because 8 take 2 is 6. Would give us that, so I know that that's got to be an 8 in there. Now the next thing I'm looking at here is something times something take 5 is 7. So if I take 5 from something and get 7, that must have given me 12. So what are the numbers that multiply to make 12? 1 and 12, well that's no good. 2 and 6, so it could be that, and 3 and 4. It could have been that, except that the 3 is there, so I know it's 2 times 6 there and there. It's just about which way round. It might be 6 times 2. So I think it's probably going to be 2 times 6. And then if I had 1 times 2, that would be 2. 2 take 5 is negative 3, but I can't use the 5. So it can't be that way round. So maybe it is 6 times 2. 1 times 6 is 6. 6 take 9 is 3. So that is possible. So it must be that one. 1 times 6 and 6 times 2 take 9. If I take 3 from something and get 5, it must make 8. So 1 plus 7 is 8. 7 plus 2 is 9. Take 4 is 5. And check. 9 4s are 36. Take 8 is 28. So that's the easier one done. Now moving on to the tougher one. Have a quick look at that. See what normally something to do with multiplications will be our way in. So pause it and have a go at harder if you haven't done already. Now we've got lots of things about multiplying up to make 28. I know that the factors of 28, 128, well they're not going to come into it. And then we've got 2 times 14 and 4 times 7. And the last number would have to be either a 1 or a 7, wouldn't it? So we've got 1 times 4 times 7 is the only way we could have 3 single digit numbers that are going to multiply together to give us 28, because if we did 2 times 7 is 14, we'd have to times that by 2 again, and we've only got 1, 2 that we can use. So it must be those through in some order. Then also we've got 10 here. We're dividing by something, then we're timesing by something. So we must have, because 10, 1 times 10, and 2 times 5, we're not going to be able to divide 2 single digit numbers and get any number other than 2 that we could then multiply by a single digit here, because we can't multiply by 10, so we can't make it down to 1, we can't make it down to 5, so it's going to have to be one number there that's twice the size of that one, and then that'll have to be times by 5. Now 8 times 4 is 32, so 8 times negative 4 is negative 32, and 1 take 5 is negative 4, so we must have a 1 there. Now I know that 4 and 7 go in some order there and there, but I'm not sure which order. I do know that I've got to divide by something to get 21 here. Now that's a bit tricky. I know that 21 divided by 1 is 21, but I've already used the 1. 42 divided by 2 is 21, so that's possible. 63 divided by 3 is 21. And what's 4? 4 21s are 84, aren't they? Now I could get 7 times 9 to make 63, but 84 is too big to get with 2 single digit numbers, and I could do 7 times 6 for 42. Now if I had 7 times 9, I cannot divide 9 and get 2, can I? Which is what I need to make 10 there. So it must be 7 times 6 is 42. 42 divided by 2 is 21. And 7 times 4 therefore is 28, and I've got 6 divided by, it must be 3 to make the 2, that I then times by 5 to get 10, and 4 times 3 is 12. 12 add 9 is 21. Now let's just check that this works. 2 take 9 is negative 11, take 8 is negative 19. That's not quite right, is it? It should, oh no, 2 take 9 is negative 7, isn't it? And then take 8 is negative 15, so we have got that right. That's a relief. Okay, always double check that last one, folks. Right, time to move on to our final main lesson. Right, so we're starting off on question 9 today. Take your time and pause the video, and a lot of maths is about being creative. People don't necessarily realise that, but it's possible to create a triangle in here given what we know about compound shapes. Now I could draw an imaginary line across here that makes this into a rectangle, and there you've got a right angled triangle up above. I know that that is 4 meters. Therefore, I also know that that's 2 meters, that length there. And I know that this length along here is 15 meters. So I know 2 lengths, and I want to know the size of angle BAD. So that means if I work this out and add 90 degrees, I know that angle BAD is going to equal 90 plus whatever x is. And now it's time to use the sine rule to do that. So if you weren't sure what to do up till now, pause the video and see if you can do the sine rule stuff. Now I know that this is a 90-degree angle. I don't know either of the other 2 angles yet, so unfortunately that means I need this side. And so to do that, that is the hypotenuse, isn't it? So I am going to need to use Pythagoras at this point. It's the longer side, the hypotenuse, so that means when we square these, we're going to add them. So if I do 15 squared plus 2 squared and hit the square root button, and I do that in my calculator, like that, it says the square root of 229, and that is the exact number. We don't really care what the square root of 229 is. If we wanted to, we could press the S to D and it's just over 15 centimeters, but we're going to use that because that's exact. Then we can say, I know I'm looking for the angle, so that means we're looking at the whole idea of sine A over A is equal to sine C over C. I say C because we're using the hypotenuse, which in Pythagoras is the one that we call C as A squared plus B squared, not plus, equals C squared. Anyway, time to fill these in here. So sine X is what we want, is over 2, is going to be equal to sine 90 over the length that's opposite that, which is the square root of 229. Now I multiply both sides by 2, and that's going to give me sine x equals 2 sin 90 over root 229. Now if I just want x on its own, I can use those three dots there to mean therefore. I'm going to sort of divide by sine, which in the calculator is sin minus 1. So you do shift and sine and then put 2 sin 90 over the square root of 229 all into that in one go. So I do that now. Shift, sine, press the fraction button, 2 sin 90, close the brackets on the 90 degrees over the square root of 229, come out of the fraction, press the close of brackets and equals, and it gives us 7.59 degrees. But that's not my final answer, because remember BAD was 90 degrees plus x, so I'm going to add 90 to that, giving me 97.59, and it says answer to 1 decimal place. That's why I did it to 2 decimal places up till then, so that I can then round it to 1 decimal place, because that 9 makes it closer to 9.6, so it's 97.6 degrees. Here's our next question then. We've got a couple of right angled triangles drawn next to each other. Pause the video and see what you can do. You are going to have to do both triangles, because we need to know one of these other lengths before we can use our trigonometry, because at the moment we know 2 angles but we know no sides at all. So for that we need to use this, and to do that we need to use Pythagoras, and this is the longest length, so I'm going to call that one C, that one A and that one B. So it's a case of saying a squared plus b squared equals c squared. If I put 16 in there, plus b squared equals 20 squared, I then need to take 16 from both sides, or 16 squared, sorry, and we have b squared is equal to 20 squared take 16 squared, and therefore we don't want the square, we want the square root, so we're going to root both sides, and b will be the square root of 20 squared take 16 squared. Put that into your calculator, and it actually gives you exactly 12. So it's always worth checking that rather than having to work with that all the time. So I now know that this is 12 centimeters, and that is opposite the 25 degrees, and the x is opposite the square symbol there being the 90 degree. So now you need to use the sine rule there. Pause it and give it a go. So I've got my x over sin 90 is equal to my 12 over sin 25. So remember, the angle always goes with the sin, and you always put, whatever your x is, you always put that one on top and then work it from there. Now we need to get rid of this divide by sin 90 by multiplying both sides by sin 90, and it gives you x equals 12 sin 90 over sin 25. Pop that into the calculator and you should get 28.39. So I write down 28.39, 2 decimal places because we want 1. Then I put the box round and have a look and say, yeah, that 9 means I round up to 4. So it's 28.4 centimeters. There's not actually a mark for the centimeters this time, even though it's not on the dotted line down at the bottom, because it asks for the value of x. It doesn't ask for what the length is. It's just a little thing, but there's no harm in putting it in there. I always do, just in case. You never know, you might get an examiner who's in a hurry and hasn't noticed that and therefore takes it off. Right, now we've saved the toughest to last. Take your time, pause it and see where you can get. Now, the angle BCD means the one at the middle there, so I'm going to call that X. In order to find that, I need to know, well, I've got one angle there, and I've got a side there, but I would also need, because I'm not going to get that other angle anyway, because I know that's 90 degrees, I need the side opposite that. So I'm going to call that Y. I can't work that out yet though. I could work that out using Pythagoras if I knew what this was, couldn't I? So if I knew what that was, let's call that W, then I would know that Y is going to be the square root of 9 squared plus W squared, whatever that is. I don't know W, but I do know the whole of this length. So if I knew this length here, I could take it from 22 and I would know W. So I'm going to do that. I know that this here is 90 degrees. I don't know that length, but I do know this length, which is opposite that. So I know I want V over sine whatever this angle is up here, and I know that's equal to 9 over sin 37. Now angles in a triangle sum to 180, so as we've already got 90 there, 37 and this must add up to the other 90. So if I make a little number line, it's 3 up to 40, and then from 40 up to 90 is 50, so that must be 53 degrees. So we're looking at sin 53. Multiply both sides by sin 53 so that I get my V equaling 9 sin 53 over sin 37. Put all of that in your calculator and you should get 11.94. We want the final thing to be to 1 decimal place, so you want to keep more than that. However, I'm going to use the answer key button in a moment. W is going to be 22 take the 11.94. I'm actually going to write answer here, because if I do 22 take answer, that will automatically use that, which gives me 10.056 if I write the first few digits down. But again, that is W, so I'm going to put in my calculator 9 squared plus answer squared, making sure I do the answer squared bit, 9 squared plus answer squared, and that gives me 13.496. But again, I'm going to use that in a moment, because I can then say that x, or sine x, because it's the angle, isn't it, always goes with sine, over 9, because that's opposite there, is going to be equal to sine 90 over the y, which is 13.496. I'm going to multiply both sides by 9 to give me sine x equals 9 sin 90 over 13.496. And then I'm going to say, I'm going to divide by sine, or find the inverse of sine, the opposite of sine, by doing sin minus 1. Put that into the calculator. When I do that, I'm going to write answer there, because that is the last thing I put in my calculator. So shift sine, open brackets, 9 sin 90, close brackets, to the bottom, just press answer, come outside of the fraction, press that, and that gives us 41.82. Now we want that to 1 decimal place, so that is the one that I round, and that's the final answer. Okay folks, that was a tricky one. I went through it quite quickly. You might want to go back and watch through it again. Okay, hope you all have a lovely weekend, and I'll see you next week.